lecture series on periodicity. This extract is from Jam Remix. Credits to them for using their item. 31. Two atoms represented as this and this are definitely they are isotopes. Option C. Right. Isotopes are elements with different mass number but the same atomic number. 32. The number of electrons in the valence shell of an element of atomic number 14 is 32 is option, let me see, is option D. You have 4 valence electron, 2 innermost, 8 outside, then 4 at the outside to make it 14. D. Which of the following physical properties decreases across the group in the periodic table? 33 is option D. Option D, electronegativity. Remember, it increases across the period and decreases down the group. Electronegativity. 33 is option D. 34. The diagram above represents an atom of. This is not clear enough. But this should be magnesium. You should settle for magnesium because if you count it 2, then you count another one at the outside 8, then this 2 outside is magnesium 12. 35. Use the section in the periodic. Would need a bit of solving board, the whiteboard to do this, the blackboard to do this. Okay, let's go. We could actually tackle this. Which of the letters indicate an alkaline metal and a noble gas? Just know that the alkaline metals are around here, while the noble gases are around here. So the noble gases are these 2, 10, and 14. While your alkaline is that's G, this first line here. So number 35 is option D. G and L. 14. Which letter represent a non-metal that is solid at room temperature? Non-metal solid at room temperature. Let us see. Non-metal solid at room temperature. It's T. This place here, non-metal solid at room temperature. T. 36 is option A. Why do I say it's T? Sulfur is a non-metal solid at room temperature. And 16 is for sulfur. Okay. 36. Which letter represent a non-metal that is solid at room? Okay, 36. 36 is option A. 37. In the oil drop experiment, Millikan determined a lot of students get this wrong. In the oil drop experiment, Millikan actually determined the charge of an electron. He determined the charge of an electron. I would like us to jot this next point down. Right. Datum established the existence of atom in the atomic theory. Number 2, R.A. Millikan measures the charge on an electron using the oil drop experiment. Number 3, J.J. Thomson discovered and also measures the charge to mass ratio. Charge to mass ratio is J.J. Thomson. Number 4, Chadwick discovered neutron. 5, Rutherford suggests the planetary model of atom. 8, Neil Bohr modifies Rutherford model and explains spectra in hydrogen. And that's the most relevant ones I would like you to keep in mind. Would run fast. 38, which of the following statement is false about isotopes? The statement that is false about isotopes here is they have same atomic number. They have same atomic number but different mass number. They have same atomic number but different mass number. Which of the following statement is false about isotopes? I think it's supposed to be which of the following statement is true. But option D is the correct answer here because the other ones are false. Question 39. I need to demonstrate with the calculation for us, with a table for us, with a board. 40. In the periodic table, what is the property that decreases along the period and increases down the group? 40 is option D, atomic radius. It decreases across the period and increases down the group. 41 has to do with a bit of calculation. 42. Which of the following electronic configuration indicate that an atom has the highest ionization energy? 42 is option A, 287. Okay, back. I would like to take this question again. Which of the following electron configuration indicates an atom with the highest ionization energy? For the 42, option B and option C. Here, B and option C. They belong to the same period. Hence, ionization energy of D is the highest. the ionization energy of option D is the highest, while B is the least. And so they're asking you the one with the highest ionization energy. With the highest ionization energy, 42, you go with option A. You get, but option A and option D, see, option A now and option D, they belong to the same group. And so 7 is greater than 7, and they belong to the same group 7. So this one belongs to group 7, this one belongs to group 7. So the one with the highest ionization energy would be this one, option A. Let me go again. Option B, C, and D, they belong to the same period. If we go like this, the ionization energy of D is highest and B will be least. But option A and D, they also belong to the same group. And again, 7, they belong to group 7. And so A is greater than D. If you check here, A is greater than D in terms of ionization energy. So option A will be the correct answer. So we said 42 is option A, right? 287. If you will need more clarity as regards question 42, you could drop your question in the comment section. For the sake of time, let's run. The line observed in the simple hydrogen spectrum are due to the emission of energy by electron transition. Energy by electron transition, such as excitation. Energy by electron transition is simple, option C. 44. You have a modern electronic configuration here. An element with the electronic configuration above is 44. It has a partially filled d orbital, so that would be a transition element, option C. 45. In order to remove one electron from 2s orbital of gaseous sodium atom, about 496 kilojoule per mole of energy is required. This energy is referred to as 45 is referred to as ionization energy. Okay, option B. 46. The distance between the nucleus of chlorine atom in chlorine molecule is, this one will have to do with a bit of calculation. I'm going to demonstrate to us. 47. Which of the following statement is correct about the periodic table? Which of them is correct about periodic table? The valence electron of elements in the same group are the same. Option A is the correct answer actually. So we said option A. 47 is option A. The valence electron of the element in the same, let's go to the other side, in the same period increases progressively across the period. Option A. Number 48. Millikan's contribution to the development of atomic theory is the determination of 48 is option A. Determine the charge on electron. 49. 4 elements W, X, Y, Z have atomic number 2, 6, 16, and 20 respectively. Which of these elements is a metal? Atomic number, which of them? You have 2, you have 6, you have 16, and 20. Which of them is a metal? 49 is option C. Z is a metal. 20 is a metal. Okay. 50. The diagram above represents the information of what kind of bond here? Let me see. This one is electrovalent bond, option B. 51. Which of the following statement is true of the proton? The proton. The mass of the proton is 1840 times the mass of electron, option B. 51 is option B. 52. The shape of the s orbital is, I want you to jot down. S orbital is spherical, p orbital is dumbbell. So option A, spherical. Chlorine has, this for 53 has to do with calculation. 54. The component of an atom that contributes least to its mass is the electron. 54 is option C, because its mass is 1840 times lighter, very light. 55. The element with the electronic configuration 1s2, 2s2, 2p3 is 55 is option C, nitrogen. 56, we are going to stop at question 60. A decrease in the atomic size and an increase in the nuclear charge across a period leads to a decrease in electropositivity. 57, the idea of planetary electron was that of Rutherford. 58, how many electrons are in the shell of this element here? 58, this question has been repeated kind of. Option C, you have 8. How many electrons are in the shell? And in what shell actually? And in what shell? I think the L shell, this question is not complete. The L shell will contain 8. The K contains 2 and the M contains 5. 59. Which experiment led to the measurement of charge on an electron? Charge on an electron. 59 is option C, oil drop experiment. Oil drop experiment. Write this point down. This charge tube experiment led to the discovery of proton and electron. Mass spectrometer led to the determination of isotopic mass. Next, scattering particles experiment led to the discovery of the nuclear core, and this was done by Rutherford. We'll stop at question 60. If the electronic configuration of an element is this, how many unpaired electrons are there? I would like to also demonstrate question 60 with a board. Now, if you got into this point and there are questions that you don't find clear or you would need me to explain more, drop your question in the comment section or you could visit our WhatsApp group. Thanks for watching and see you in the next video.